Hello, and welcome to episode 3 of Thick Sustainable Infrastructure Finance. Today, Bill and John will review an example of thick restorative infrastructure. Bill, would you define for us what thick restorative infrastructure is, what it does, and why investments in it are accretive to our efforts to evolve to a sustainable future?
As we discussed in episode 2, thick sustainable infrastructure falls into two broad categories: resilient and restorative. As a quick review, restorative infrastructure seeks to preserve and restore natural capital, moving us closer to a balanced relationship with the environment. From an investment perspective, these are long-term projects with, in many cases, persistent returns over the duration of the bond term. Beyond the investment term, these projects will continue to benefit humans and the environment for decades. So when we consider returns more broadly, the environmental benefits compound significantly over time. In this case, the city of San Diego, being at the end of the water supply line in California, was one of the first municipalities in the United States to face some of the hard facts about water scarcity. John, can you take us through their challenges?
Thanks, Bill. Sure. So, as most of us know, San Diego sits at the end of the line in terms of the water supply from the Colorado River. California is also a semi-arid geography. So both of those conspire to force San Diego into an artificial water shortage. With longer periods of drought and a growing population, they're faced with a choice, two hard choices really, between desalinization of ocean water and recycling of wastewater through water purification, converting their water system into a closed system. Desalinization is very costly and very energy intensive. Desalination would have an adverse impact on climate change. Water purification and conversion to a closed system is no simple thing either. Just the conceptual nature of taking water from a waste treatment facility and putting it back in at the head of the pipe and using it for drinking and other purposes causes pause for many. But in this case, given those two choices, San Diego opted for the recirculation system and now operates a plant that allows their water system to be essentially closed, with some notable exceptions. This is a really cool project. This technology delivers environmental benefits in all four forms of environmental capital: energy, water, atmosphere, and habitat. So going to the next slide, specifically, the big contribution this project makes to thick sustainable infrastructure is in its use of treatment equipment that allows wastewater to be returned in the water system to supply water. It allows water that would ordinarily be discharged to the ocean to be returned as potable water for use in the system, in addition to being used for non-potable sources such as irrigation and manufacturing. So it really cuts down on the demand San Diego has for water from the Colorado River basin. In addition, this program reduces the discharge of treated wastewater into the ocean. It watches the temperature of that wastewater, and it helps preserve the local habitat. So it gets a score for water, it gets a score for habitat. The system captures methane gas and uses a solar panel to produce electricity. So it's carbon neutral from an electricity perspective. And so as you can see, the way we've scored the project, this is a winner in all four of the categories of natural capital that we measure. So this project is one that clearly helps build that bridge to a sustainable future.
Thank you, Bill and John. Stay tuned for more examples of the thick, sustainable infrastructure needed to meet our global challenge. If you haven't subscribed to our channel yet, please do so. And as always, please let us know what you think. We always learn from our colleagues.